Now, it is impossible.
Hello, me for the last time.
There's
There's going to be no camp this time, there's going to be no gorilla this time. Someone's given me the advice, never work with small children or animals. So no gorilla and no camp. You can decide which is which, okay? Now, the last thing I want to do is I want to talk about linear independence and linear dependence of a set of vectors. Dependent, if we have a set of vectors, call it vector A. You might be asked to show the set of vectors is linearly independent, etc. Which means, and in the special maths exam, you're probably not going to have more than 3, and you're going to show that you fail, then we say that those vectors are linearly now, we'll look at a little example. Now, kind of modify this example. You can take some clever this combination of them in exam 1, specialist maths exam. I've just made a little modification to it and get the 0. Make it a little bit more challenging. All right. The alpha, the beta, the gamma. Like a little, they're symbols in the Greek alphabet. I believe Greece is actually. Let's say we've got a couple of vectors. We've got the vector A, their debt. Anyway, alpha, that's 2k, beta, and we've got the vector B, and that's their scales, their real numbers. Okay. If you can find numbers like alpha and beta and gamma, such that when you multiply the vectors by them and add them all up and get the 0 vector, then we say that the set of vectors is linearly dependent. If it's impossible to do that, if it just can't be done, then we say that they are linearly independent. Now, just as a little side note, the set of vectors I, J, K, those unit vectors that we know and love, they are linearly independent. Okay. It is impossible. Now, how am I going to show you some of these things? I'm going to try. Some of these things might be 0, but they're not all allowed. So they're not all dependent. And I'm going to say, well, now it is impossible all of those except for those ones I just found with the vectors I, J, and K. So I'm going to start off by trying to make them dependent to get what that will mean. Plus gamma k equaling the 0 vector, unless you're alpha. That little thing I said earlier, by the way. Right? So, now, often you might be asked to show that a set of vectors is linearly dependent, in which case this is what you're going to try and do. You might be asked to show that a set of vectors is linearly independent, right? But there is actually an easy way this is what you're going to try and do, and you're going to show that you fail. Because if that is true, it will also be true. Okay. Now we'll look at a little example. Now I've kind of modified this example from actually this year's 2011 exam 1, specialist maths exam. Just made a little modification to it. The vector you chose from the other to make it a little bit more challenging. Choice the exam was dead simple, so let's make it a little bit more challenging. Alright, so we've got a couple of vectors. We've got the vector A, a bit difficult to use. That's I. I'm going to use this opposite way of thinking about it. That they'll be dependent. And we've got the vector B, and that's equal to the vector I plus 2j plus mk, where m is some number, we don't know what it is. And C is the vector I plus j plus k. Our job is to find value of m such that A, B, C are independent. Okay. Now, how am I going to show they're independent? I'm going to try and make them dependent, and then I'm going to give a value for m that'll make them dependent, and I'm going to say, well, except for those ones that I just found. Okay? So, I'm going to start off by trying to make them dependent. Now, what that will mean is I need to take a combination of the A and B and C. Now, that little thing I said earlier, by the way, that alpha A plus beta B plus the gamma C and the 0 vector, there is actually, that's the technical definition, right? But there is actually an easier way to do this, alright, without worrying about technicalities. Because if that is true, it will also be true that you can take one of the vectors, any one of them, A, B or C, and it will be true that by finding appropriate values, you can basically construct the vector you chose from the other two vectors. by a choice of numbers. So they're real numbers as well. All right. So rather than using this definition, which can be a bit difficult to use, I'm going to use this alternate way of thinking about it, that they'll be dependent if I can express one of the vectors in terms of the other two. My cameraman is yawning away here. I'll try and be more exciting, I promise, Mr. Boney. Okay. Actually, my audience is probably yawning away as well at the minute. They're probably wondering if the gorilla's going to come back. Anyway, so I'm going to take, just randomly, I'm going to pick the vector A. And I'm going to assume that I can write the vector A in the form of some number times the vector B plus some other number times the vector C. Now, if I can do that, that would mean that A and B and C are linearly dependent. So for whatever values of m I can do this for, I don't want those values because I need these things to be independent. All right? Now, I'll put in what A is. Now, my vector A was I minus j plus 2k equals. Now, I'm going to do all of this at once. All right, I'm going to do all of it at once. Now, we can actually stop the clip at any time. So I'm going to, no, I'm not going to stop it now. It's good stuff. It's gold. No, but we can stop the clip that you're watching right now. We can just I can just press the button, or whoever's actually there in real life, you can press the button, we can stop, and you can kind of confirm that this will be true, and then then we'll continue it going again. Now, mu b plus lambda c. That is actually going to equal I outside of. Now I'm going to have a mu plus a lambda. It's going to be a j outside of, and I'm going to have a 2 mu plus a lambda. And the coefficient of k is going to be a lambda m, a mu m, no, hold on.
That should be a mu.
That should be a mu, yeah. Should be a mu, now we're working. And it'll be a m mu plus lambda. So all I've done is I've put the vectors a, b and c into here. This side I've expanded all out and I've grouped the components together, and that's what I end up with. And you can check that and you'll see that I'm right. Okay. Now, if these two vectors are equal, that means that their components have to be equal. So, the component of I here is 1. So we need 1 to equal mu plus lambda. Call that equation 1. We need -1, the j component, to equal 2 mu plus lambda. And finally, we need 2, the k component, to equal m mu plus lambda. Now, what I'm going to do, I'm going to solve them simultaneously. I'm going to get a value for m. That'll be the value that makes these guys linearly dependent. And I'm going to say, well, my values of m that I want for the question will be all real numbers except for the values of m that I've just found. Okay? Now, looking at equations 1 and 2, a simple way of solving 1 and 2 would be to take equation 2 and subtract from it equation 1. Now, if we do that, -1 take away 1 is -2. 2 mu take away a mu is a mu. And a lambda take away a lambda is no lambda. So we get mu is equal to -2. Now I can put mu is equal to -2 into 1. So sub mu equals -2 into equation 1. And we'll get that lambda is equal to 3. And I think that works, doesn't it? Check it in the second one. 2 times -2 is -4 plus 3 is -1. That works. Okay, brilliant. I'll just rub out this little bit. We don't need it now. Okay. Now, if I know that lambda is 3 and mu is equal to -2, I'm going to sub all of that into equation 3. Now, if I do that, I'm going to have 2 is equal to, now my m times mu is going to be -2m, plus my lambda will be 3. And so, therefore, we'll subtract the 3, and we get a -1 is equal to -2m. So therefore my m is equal to 1/2. Now, so in other words, if m is equal to 1/2, these three vectors are going to be linearly dependent. I want the values for which they'll be linearly independent. So in fact, I want every value of m except for this one. So my answer will be, m can be any real number except for 1/2. If A, B, C are independent, linearly independent. So it's well independent, isn't it? I don't really care now, it's been so long. And I think that's about it.